notes first, because it's important for me to show you the notes. I will present the screen. And before that, I'll start the recording. So, how's everyone today? Now is our week 8 already, halfway through the semester.
Week 8 halfway. Oh, yeah. Oh.
Week 8. Right, we are in week 8 already. And this week we are having a program audit for our diploma in IT. So lecturers a bit busy lah. I hope my Thursday class will not be affected. Okay. I have class in the afternoon with you all, right? This virtual audit, MQF virtual audit. Okay, so the first question here, 9 marks. Types of improvement or services, so 3 marks each. Let's see, types of improvement. This one should be in our chapter 2, which is on the system planning. In our chapter 2, we learn about, we start from the system request. We receive system request from the user requesting for the new IS project. And these are some of the sources of the system request. Means the system request is from either it's from the top management, or is it due to the existing system, and so on. But then our question actually asks for this one. Farah, the types of improvement required. So you can either say improve performance, better service, because if you refer to the question, yeah, airline company, they want to replace the airline system, and then the current system was implemented 10 years ago and is now facing some problem. Okay, some problem, and the new airline system covers the following functionalities. So you can make your own relevant and logical assumption. Now, in this case, if we already know that the current system is having problem, then the best answer would be improve performance, because the current airline system is having problem. Okay, and then when the current system is having problem, I believe it will affect the service to the their passengers, to their guests. So you can also add better service. And then quality information is also acceptable. Perhaps you can mention about the guests making the booking, unable to get sufficient information. Okay, because the question said that you can make any logical assumption. All right, I believe Kelvin, you answered effective controls, right? Okay, I accept your answer as long as it's logic makes sense, should be no problem. And reduce costs. This one is also acceptable as long as your justification is based on the airline system. Okay. And the next question is, so Farah, you're clear about this one, right? Okay. And then with reference to the above scenario, briefly explain the technical feasibility and social feasibility. Technical feasibility means can we build it? Okay, can we build it? Let's see. I think it's somewhere here. Okay, so it means that they need to evaluate whether the hardware that the airline has, okay, the software, even the human requirements, okay, are technically achievable or not. So you need to mention this, okay, whether they have the hardware to handle, say, for example, a number of users, okay, or perhaps they have the human requirements to like operate the current system. Okay, that is about technical feasibility. If you mention this too, you get full mark. Okay, as long as you mention the airline system, and another one is the what was it? Social feasibility. Social feasibility here, whether the project, okay, here you can replace the name as the new airline system can fit into the existing social and operational structure of the airline company. Okay, as easy as that, you just need to replace the name, all right, and then rephrase it accordingly. And then if there is any additional cost that need to be incurred, it means that if they want to implement the new airline system, they're able to handle the cost of retraining the staff to so that they can use the new system efficiently and so on. Redundancies means whether any of the staff need to be their service need to be terminated and so on. Okay, so that is a social feasibility. Next is potential benefits. Okay, I accept any tangible or intangible benefit of using the new airline system. So your explanation should be talking about the airline system. Okay, do reduce operating costs due to streamlining of the what process. Okay, so you can refer to the question. What are we talking about? About the ticket booking process. Okay, and so on. And then increase sale revenue through customer retention means the passenger they are happy with making booking through the system, all right, which encourage them to keep on buying tickets, okay, airline tickets from them. So these are some of the examples. And for the intangible benefits, quite easy. Improve what? Improve the airline company image. Okay. What else do we have? Improve quality of customer service. These are some of the benefits. Okay. Mm-hmm. Okay, you have a scenario here. A retail chain store has a network of 500 retail stores. This is quite a big number of stores. And then it's in major towns and cities of the countries, means throughout the country. They have a centralized purchasing system, right? At the top management, they want to have a new procurement system. Oh, procurement system. I suddenly I remembered something. One moment. Whose answer is that? Let's see. Let me double check. Yeah, you all are looking at your own answer, right?
Yeah.
Oh yeah, Farah punya answer. Okay, okay. I think I need to remove there's a dash there. Okay, okay. Farah, if you see your question 2A, answer 3, there's a dash on the procurement system, kan? That is a mistake from me. I should not have cancelled that one out. Okay. Now, here this question actually asking whether, or not whether, what are the three situation or scenario where it's much better to use questionnaire. Okay, so for that one, I believe we can go to
Circumstances damn it.
which is, let me go to chapter 3. Yeah, chapter 3 for fact gathering system analysis. Fact gathering system analysis. So we have all this questionnaire. I think this one, Noel. Okay, Noel. Circumstances where it's suitable to use questionnaire when there are large number of users. So it's true from our scenario, right? And then geographically distributed users, yes, throughout the major cities and towns in the country. And also the next one is factual information. As long as the justification is relevant to the company, retail chain store, then your answer is acceptable. Okay, 9 marks. Um, okay, three ways how the interviewing technique is better than questionnaires for gathering facts.
Consequences.
Three ways. Three ways. Mm, so you can mention this. The one that I want to point out in your answers, please check your answers. Um, for the clarify of facts. This is the advantages of interviews in gathering the information from the user. So your explanation should be from the interviewer point of view. Okay, if you look, Noel, you misunderstood effect. I see. Um, I think your answer, I'm not sure. Two of you or three, two, when you explain about clarify facts, you explain it from the interviewee point of view. Here you need to mention that um, it is how the interviewer, which is the SA, gather information from the user. Okay, what is the advantage, right? It means that interviewer himself can clarify the confusing facts, okay, or verify the confusing facts. um, okay, and then finally, this is from the interview narrative description and the answer. Let me share you with the answer. If you notice there's requirement for you to resolve any many to many relationship. No, so when there's no requirement, then no need for you to resolve it lah. Okay, so you will get 5 marks for 5 entities. It's very clear here. The store one, the PR purchase requisition two, and then item three, and then RFQ four, and then supplier five. Okay, 5 entities, you get 5 marks. And then with the correct relationship, 4 relationships. Okay, I will check the cardinality in at both ends. So let me show you the correct diagram. I think Noel, you got it correct, except that there's no need for you to what do you call that? Resolve the many-to-many relationship. So store to the purchase requisition is one to many. Okay, this is the many-to-many relationship. Purchase requisition and the item, and item and RFQ is one to many, right? And then RFQ to supply is one to many, minimum zero lah. Okay, and notice that I think Noel and Kelvin, both of you resolved the many-to-many relationship. So what I will say is that here you put the associative entity, which is the bridge entity. Okay, I will see whether um, the two one-to-many relationships are correct. So if this is many-to-many, your bridge entity is in the middle, then you should have one-to-many, many-to-one. So at the bridge entity is where you should have the foreign keys, the many relationship. Okay, if you get that correct, so I will treat that as a correct answer for the relationship between the PR, purchase requisition, and item. Okay, so is there any question so far?
No.
Okay, no.
No.
So I like what I mentioned in the my email. That one is yet to be reviewed. So I'm waiting whether my reviewer will agree on how I give marks on the many-to-many relationship. Okay, and for the others. All right, and then there's a dash line. I think Calvin, you use dash line. Mm,
Yeah.
we didn't cover that in detail, right? But I think in database you'll learn the dash line, correct, Calvin?
Yeah. Yeah, I use it correctly.
Mm. So I hope my reviewer will take note on that one. Lah. Okay. So that's all for the test, right? Okay, next. So for today, we are going to cover chapter 8. All right, so we are done with the design, system design. So if you're ready, okay, let me start now. Okay, we are now in the system development, right? In some books, they don't have the system development as separate phase in SDLC. In fact, they assume that the system development is in the system implementation phase. Okay, so just to give you a recap, okay, I took this from our previous chapter, the diagram. And I think I saw Noel and Kelvin attended the software development talk by Mr. Bob Jalius. He mentioned a little bit about software development. We have waterfall and also agile. And as what you can see, SDLC is a waterfall model. So to show that SDLC is a waterfall model, I redraw the lines. Okay, in fact, in other books, the lines should be like this, right? Whereby the first phase is a system planning. This is where we conduct preliminary investigation, and system analysis is where we conduct the detailed analysis. So we don't want to waste our time and money conducting a detailed analysis in the second phase of STLC. That's why we do the PI, the preliminary investigation in the first phase of STLC. Means the feasibility study, the three feasibility study: economic, technical, and then we have the operation, social and operation feasibility study. So if the project proposed system is feasible, all right, then the what you call that, the user as what Mr. Bob mentioned, normally the government they use this waterfall model because of the documentations. They focus on, they emphasize on documentations. That's why at the end of each phase in SDLC we have all this documentation before they want to allow the system analyst or the system developer, software developer to move on to the next phase, they want to go through the documentation, give their approval. Once they're approved, like say in the preliminary investigation report, it shows the remember what we did in system planning and also for your case study, you come up with your cost and benefit summary and all, right? And then see whether it's visible in terms of economic and so on. So that one will be in the preliminary investigation report. Okay, in the preliminary investigation report, everything is okay. You get green light from the user. All right, then you will go to the next phase, which is system analysis. Take note on my arrow is different from our previous diagram where here the system request will be the start of our SDLC, okay, the software development life cycle, and this phase will produce this deliverable or output, the PIR, which is used as the input for the next phase. So you can see this is something a waterfall model. Okay, let me show you something. Different books that have different diagram. I want to show you. Okay, this is from my another um, another course for the business student, accounting and diploma. Yeah, this is the diagram that I use for them. Okay, so you can see that it looks like a waterfall model. Okay, going down, going down, going down, going down, going down. Okay, SDLC is a waterfall model whereby each phase is connected by another phase by their inputs and outputs. That's why, okay, the output from this phase, okay, becomes input for the next phase, right? That one is just an extra. Okay. Um, so what we have covered so far, the first phase, second phase. So the second phase is where you learn about fact gathering or fact finding first, okay, and then in chapter 4 we covered the fact recording, right, the fact recording. So everything that is gathered will be properly documented in a SRD, the system requirements document. And previously, we have managed to finish system design, whereby in order for the SA to come up with the system design, he needs to go through the requirements document first. Okay, go through the requirements document, like what are the functional requirements of the system, the non-functional requirements of the system. Okay, how do SA know all these requirements? We have learned the interviewing technique, questionnaire, which you also have done for your case study, right? And so on. So the system design that we have covered last week, we have completed the procedural design, where that is how we record the logic of the processes in each of our say when we draw the DFD, we have the main processes, right? In order for the programmer to code it, we need to come up with a procedural design. So you learn, what did you learn? Structured English, decision tree, and also decision table. We didn't focus on the pseudocode and flowchart. Okay, so the system design will be compiled in a document called System Design Specification. Um, what we have covered, user interface design, What else? The report design. When we come up with the input design, right? The UI design, you need to have the input data validation. Then you have the database design up to the procedural design. So everything will be in the SDS. All right. So there are quite a lot that we have covered so far. So now is we are in week 8. We will finish off the rest of our phases in SDLC. This is to show you where are we now. Okay, I don't want you all to lose track of where are we in the SDLC, right? So the system development will start with the system design specification. Okay, so to summarize, you can refer to your chapter 1. These are slides from the chapter 1. Okay, a very good recap, okay, for you to go through what we have covered so far in system planning, okay, in system analysis, okay, and system design, where for the process we learn the procedural design, okay, structured English, decision tree, decision table, and here we are at the next phase, which is system development. As what you can see here is code test document. So chapter 8 we will cover the first one. Okay, and then next week, chapter 9, we'll cover the other two. Okay, the system testing and system documentation. So for chapter 8, we cover this one only lah. So once the system has been developed, so what happened? Okay, after it has been developed, then you have a completed system. Okay, it has been completed, and then the next phase is the system implementation. System implementation is where we will do changeover. Means we stop using the old system and we bring the new system into operation. That's why here the output from system implementation is operational IS. Okay, operational IS. And then the operational IS will be getting what we call as maintenance from time to time. So that is to give you a preview what we'll cover in the next few chapters. Okay, the last one would be the system operation and maintenance. Okay, just to show you again where we are, since we are already at the middle of our semester. Now, to see whether you still remember what we have covered in system design, so I've prepared a quizzes. Okay, so I prepared a quizzes. Let's see. I think it's already been posted in our Google Classroom. Yeah, it's already been posted. So before we continue, yeah, this is the one. I want you all to do this one first, a quick 15 question. All right. Okay, so I can see all of you have completed the quizzes. Pero you need to study. Let's see the overview. Question 1, question 2. Question 1 is, what happens in the system design phase? The answer is yes. Okay, right? Code is produces what we're doing now, which is in the system development, not in the system design. Okay, and question 2 is, these are types of data validation, except we don't have double entry. This is this is for accounting. Pero we do have the size check, yeah. Okay, we do have the size check. Okay, what else? Question 5. Question 5. Let's see, question 5. Logical. We learned this earlier on, okay, in the previous chapter. Can be found in the system analysis phase. So physical design is in the system design phase. Okay, system design phase. I believe if you go to the first chapter on system design, we have that particular diagram showing you the logical design and physical design, the difference. Okay, what else? Question 6, 8, 9, 10. Question 6, um, data, the answer is data validation. Okay, the input data validation. And you need to remember this because one of the thing that you will do for your case studies on the input data validation, right? 6 and then 8. Benefits of low coupling. We covered this last week. Okay. Okay, low coupling means if you make any changes on one module, it will not affect the other module. Okay, so answer is A. Okay, and C. Okay, 9. Which among the following is true about decision trees? Alternative, yes. Can be defined to define complex relationship, yes. These are correct. Which question? 8, 9, and 10. Okay, question 8, 9, and 10. 8, 9, okay, 9 and 10. Consistent design. Consistent design is this one, making your user interface consistent in that comparable operations should be activated in the same way. And this is in our first chapter of the system design. And do take note on this one as well, because I believe you will need to design your interface screen, if I remember it correctly. And then what else? 12, 13, and 14. 12, not the benefit from using modularization, answer is C. To increase algorithm performance, no. Modularization, if you remember the top-down design, we separate the big problem into several smaller problem, means by modules. So when you have all these various modules, then understanding is much more easier. We can reuse the code and there's no redundancy. Student file is a master file, yeah. Okay. I believe we did mention this when I go through your DFD. Okay, last week. Okay, 14. The answer is not a multiple level break, because the question say this lecturer only teach one major, which is computer science, so no need multiple level break lah. Only a single level break for one course, and then the average score here for every classes. So we must have C, right? So in each of the page, there's a page break, and then for each of the average means there's average score for each classes. So that one is a single level break decomposition. This one you got it correct. When we have this, then we are talking about modularity. Where's the modularity? Okay. So how was it? Does it? Okay, I will end the assignment. Yes.
Quite challenging.
Quite challenging. Yeah, because covers how many various types of system design, right? Database design is there, report design is there. What else? Procedural design, not so much on only on decision tree, user interface design, input design, and no need to worry. This is you didn't do any revision, no? Okay, just depending on what you remember. Okay, so before we start, I'll give you a 10 minutes break before we continue with the lecture. Okay.
Well,
I take mine and other people one. I thought dikasih separate to plastic. That's why I take one.
Okay, so I'm back. Okay, we'll continue with the lecture. Let me start another recording. You're ready, kan?
Okay.
Okay. I'll present my screen now. Okay, so for this week chapter 8, we focus on the code part. Okay, this is from the chapter 1 recap just now. Under system development, there are three important things: coding, which is to write the program; testing, to test the program; document is we are referring to the documentation. Okay, user documentation and system documentation as an example. Okay, so we will cover the first one for this week, whereby if you take a look at the program development stages here, okay, this is in much more detail. I believe you still can recall that on Saturday, Mr. Bob did mention about the program development life cycle, right? Okay, so what we have in this slide refers to our SDLC. Well, these three boxes here refers to our system design phase, and the first two boxes, these are from the system analysis phase. Remember that the output from the system analysis is system design, sorry. This is from the system design phase, and this is for the system development phase. Okay, let me bring you back to the diagram one more time. Okay, so what we have as the output or deliverable for system design is the system design specification. Okay, so how are we going to use this for our system development phase? So you can see here that the first step is to review the system design document. Okay, review everything. And then the system design will include our what you see here is a procedural design, right? The decision table, the structured English, and so on, right? And then the output, which is the system design specification, will be referred to by the programmers when they do the coding. Now, to do the coding, this is where the programmers will write the program instruction. What we will cover in this chapter, towards the end, the most important thing would be using the case 2. Okay, using the case 2. And besides that, we will also look at all this briefly, because all these tools during program coding will improve the productivity of programmers. Okay, that is what we want if we want to meet the deadline of delivering the completed system to our user. Next week, we will cover the program testing and also documentation, right? Okay, for the program design, we have seen this. Okay, example is the structure chart. And for your case study, you need to design or to come up with your FDD, functional decomposition diagram, which is based on your GFT. Okay, so say if you have a process called prepare purchase order, then it can be broken down into two submodules. First one is to process the purchase request, and another one is to process purchase order. And if this can be, say, further separated into submodules, then you can see that read purchase request is already at the primitive level. Okay, display purchase request item, select quotation, print purchase order. These are at the primitive level already. If I'm not mistaken, one of your case study requirement is to come up with the functions for your submodules. So this is one of the example. The functions say you need to describe what are the four functions of the or will be done by the process purchase order. So you can list out these particular steps of process sub processes. Okay. We will, since SDLC is a structured approach in system development, so what we are covering in the system development phase, we focus on the structured programming as well. For structured programming, if you want to see from the history point of view, it started in 1960s. Okay, this is where the structured programming is was introduced, because during that time they already realized that they need more readable and understandable codes. Okay, and in the 1970s, they already have this top-down partitioning. Okay, uh, remember one of the question in your quizzes is the decomposition, right? So this is same thing, top-down partitioning. When we have this, we are doing a modularization, okay, module development. So we go for high modularity because we want to have a flexible and maintainable system. But then there's some issues, okay, issues where the programs tend to um, being developed without fulfilling the user's requirement. Okay, this is where now, okay, there's an emphasis mentioning that for SDLC, in each of the phases of SDLC, we need to involve the users, especially during the system analysis, where we want to gather all the facts from them. Okay, but then before that, during system planning, we need to include the users as well, because the moment they submit you the system request, you need to find out whether okay, the source of a system request, if it's due to the existing system, you need to gather info about that, right? To find out whether the problem is real, whether the opportunity to develop the system is there or not. So we need to involve the users, but then during the system development phase, we don't really involve the user. This is where the programmer will do the coding. So, but we will include the users during the system development after the coding, which is during the testing. Okay, so this is where we'll get the user to do the testing. So you can see that we must involve the users. So this is the lesson that we get from the mid 70s. Okay, expensive and good programs, but then to wrong problems. Okay, the reason why they don't want to involve the user in the system development life cycle is that the user cannot explain what they want. They cannot explain what they want. So here you must understand what is the definition of a structured programming. Structured programming, we go for a well-structured modules. Okay, so we have the system design. Remember our system design specification. We want to translate our system design specification into well-structured program modules. The three good characteristics of the system design, what we have covered last week, the high modularity, low coupling, and then high cohesion. Yeah, because of this, we want our modules to be readable, understandable, modifiable. Definitely, we can reduce the program complexity, because when we are coming up with the solution, it's by modules. Okay, and at the end of the day, the program logic will be focused on, right? And the module will have exactly one entry point and one exit point. I'm sure you have learned this in your problem solving programming. The three basic structures, which are the sequence, selection, and repetition structure. Okay, so I can recall what Mr. Bob mentioned last Saturday about, I did ask him, a student might have fear in coding. Um, does he have any advice to student regarding overcoming this fear of coding? And if I'm not mistaken, he did mention for student, okay, as long as you master this, okay, sequences, the basic as long as you know the selection and repetition. He mentioned the if else, okay, and then the while loop, do while loop, okay, or the looping. These are the basics that are necessary, and then do more practice. Okay. Before I go to the next topic, all right, what is the next topic? Code the program. Okay, I think I can cover this one a bit. The three basic structure in the programming. The first one is the sequence structure, means step by step. Remember, you have the start and end, and then sequence means one step after another. For selection, it's easier if you have a diagram. In this case, it's a flow chart. Whenever you see there's a diamond symbol, that's a condition, okay, a decision. So you will ask question here, this is condition. If it's yes, okay, if it's true, then you will perform this action. Otherwise, you will perform this action. This is an example of using if-else structure. Okay. And then for repetition or looping, again, you have the diamond symbol. Okay, this is a condition, checking whether the condition is true. So it depends which part of the statement that you want to loop or repeat. Okay, so as long as it fulfills certain criteria, then it will be repeated, right? So these are the three basic structure. The one that I want to grab your attention is about this. Okay, this statement: expensive and good programs to wrong problems, not meeting requirements. Little input from users as they have difficulty conveying what they need. Okay, so let's see. In fact, I've come up with another quizzes, but then this is to, I think I will give this quiz to you all, whereby this covers all the phases in SDLC, perhaps towards the end of our semester. These are some of the class activity that I have. Because just now I mentioned about this, right? Not meeting requirement. I think I want you all to do this. Okay, it's about, this is a question. So for a question, I can use YouTube. Okay, I can use an image or any link. So for this one, I have this image. Okay, the question here is, failure in systems analysis will mean more money and resources need to be spent to complete a system project, while all previous efforts are down in the drain. Do you agree with this statement? Explain why or why not. You can include a website link or a YouTube video to accompany your answer. So you can reply to each other. You can even edit your answer. So this is something like a collaborative learning in Google Classroom. Okay, so due date, let me give you today lah. Okay, means by tomorrow. I click ask, yeah.
So one student, one question, one answer.
Yeah, yes, collaborative learning. You can open it. This is the diagram. The customer explained they want this. And then the project leader understood it as this based on the customer explanation. And this is how the SA designed it. This is how the programmer wrote it. And this is how the business consultant described it. And regarding the system documentation, there's nothing. During the system operation implementation, this is installed. And customer, how much they need to pay. And regarding the support and maintenance, this is how they perform support. Just chop off the tree. And at the end of the day, this is actually what the customer really wants. They just want this tire swing. But the problem here is the user, they can't really explain themselves. So that's the problem with this one. They tend to not involve user because user that don't have any background, then they cannot explain what they want. So this is one of the problem, like not meeting requirement. Okay. So I will let you all answer this. Okay. Due is tomorrow. Okay, let's continue with code the program. So this is where we are covering this part. Okay, the code. And so in this slide you can see the purpose of coding. Coding, what does it mean? We write the program instructions. So using any suitable language. You have learned using C++ or visual programming. I think it's Visual Basic, right? Okay. And then based on the program design, if you look at our SDLC, the SA will prepare the SDS, the system design specification, right? If the system design specifications, they are complete, and then for the procedural design, say the structured English or the decision tree or decision table, it's very clear. Then when the programmer do their coding, it will be much more simpler to understand. For a very large program, then the modules will be assigned to a number of programmers. So it depends. Okay, sometimes one programmer in charge of one module, so one programmer in charge of two modules, and so on. So the question that we see in this slide is, what do you need to consider when you want to decide what programming language to use, which programming language to use? If you are the SA, and then this is during the system development, you receive this project, okay, already get the green light, it's feasible, you already get the requirement, you have already designed, now you are developing it. So how do you choose a programming language? First of all, you can look at the purpose of the language, because different language, they have different suitable for different things. Okay, like C and C++ is meant for normally for system programming, like JavaScript, HTML for web-based application, and so on. Another thing that you can consider would be the programmers themselves. Are they familiar with that particular programming language? If they're not that familiar, perhaps you can give them training, or perhaps hire a contract-based programmer for that particular project. Okay, and then another thing is the feature of the language. Okay, there are certain things that the SA need to consider. Normally, we look at the, what do you say, the cost of the language. Okay, the tool, because the cost, it will involve for say the license, it depends on how many PC, means user per user, how much they need to pay, and so on. And then for certain application, we do have this open source language, open source IDE, right? And then another thing that is important, sometimes for open source, the support is not there. But certain language like R language, which is mainly done for data analytics, they have a very good community support. There are lots of libraries out there where everyone can use, okay, everyone can come up with their own libraries and share with everyone. So with this type of libraries, okay, community support, then programmers can do their coding. Cancel installation. No, I don't want to restart. There was a do the coding faster to speed up the coding. This is where we are looking to about the productivity of the programmer. What else can I remember from the Saturday talk? Mr. Bob, he also shared that he's not a full stack developer. He mentioned about the front end developer, back end developer. There's a full stack developer means he can do both front end and back end. But then he said that he's a full stack developer. Full stack means he pull things from the internet. So it depends on the language. If there's a great support tools, people share the libraries and so on. Okay, and it can increase the productivity of programmer. Why not, right? And then there's another criteria, which is the performance, refers to the efficiency of the programs. This is again, I also remember. I'm not sure whether Kelvin and Noel, you also remember. He mentioned that if there's, I think this is from Miss Lee's question. Miss Lee asked, what happens if there's a bottleneck, means there's a problem cannot be solved. He said that eventually there's a solution, but sometimes in the expense of affecting the performance of the program. Okay, so this is where the decision to choose the programming language comes in, right? Whether the program would be resource hungry and take up large memory space. So if yes, then it will affect the efficiency of the program. It will be slower. It can be done, but it might be slower, right? In this slide, okay, the first one shows the generation of languages. I'm sure you have seen this. First GL, second GL, third GL, fourth GL, fifth GL, and this is by the specific languages. You have learned HTML with me last year. Okay, and then C is the predecessor of the C++. And then I know that you're taking COA, whereby you also learn assembly language. This one is in the 1950s. And before that, they are using machine language, the zeros and one. Okay, so this is the levels of the languages. Now, the first generation language, we call it as a machine language because they are in zeros and one. Zero and ones are what the computer can understand. If you take a look at this example, they are not entirely in zeros and ones because normally in machine language, they are frequently converted to hexadecimal, the 16, base 16. Easier for human viewing. Otherwise, then you will get yourself dizzy looking at all the zeros and one. Okay, the second generation language, you can see there's a typo here. It's MNE, okay, mnemonic. Assembly language uses mnemonic codes. I believe you have started to do your assembly language programming. Is it correct?
So yeah.
Okay, so like add this is the registers. You have AX registers, AH, AL, BX, CX, DX, right? Like why we said it is using mnemonic codes. Machine language, they are using zeros and one. Assembly language, they're using mnemonic codes. Mnemonic means easy to remember, like EQ. This is something like equivalent, all right, meaning to replace the symbol with a certain label. And then st means to store. Okay, store this value to this memory. Sr, I believe Sr is subtract. Okay, subtract. Okay, so these are some of the mnemonic codes. Third generation language, these are the high level language like C++ and Java. But what you see here is not the language itself, it's just the, I would say, the pseudocode, or perhaps is it, I think this is a pseudocode, okay, or structured English. It looks more like a pseudocode. And for the fourth generation languages, fourth generation language starts in, here, right? Okay, mid 70s, right? Mid 70s. They are more user friendly because using English. When it is more English like, what does it mean? It means the end user themselves are not the programmer. They can develop their own application. We call that as end user application. And then another feature of fourth generation language is there are lots of tools. Okay, tools that can generate the codes, tools that can generate the report, and so on. So we go for this type of tools. We want to have a higher productivity for our programmers. And another feature of fourth generation language is that they are non-procedural. Non-procedural, it's not like what we are doing where in our code, we tell the computer what we want the computer to do. We write the instruction for the computer what they should do. For non-procedural, it means the end user can just specify what they want to see, the results. So a good example would be the SQL, yeah, the query language. Mm, I believe you have seen the query report for Oracle. Okay, for query report, you just specify, okay, what you want to see. Okay, used to request the system to display reports based on a specific query. Another, besides query language, we have the report generator. I think these are all examples. We have the query language, also known as report generators, application generators. Okay, so for report generator, this is where user can use a drag and drop. Okay, it's very easy to come up with a report layout by dragging what you want to include in your particular report design. And similar to report generator, the application generator is generating codes for you. This is cool, where you just specify what you want, and then the application generator will automatically generate the source code for you. I encounter this for Java language. Normally for a diploma student, we start teaching them Java using JCreator. JCreator is a very light IDE where everything needs to be typed, right? Everything needs to be typed starting from you start the program until you end the program. Everything needs to be typed out. The reason why we insist students to use JCreator is that because for their final exam, they need to memorize codes. So they need to remember all those codes. But the following semester, we introduced them to, what was it already? NetBeans. NetBeans is a heavyweight IDE. it's quite heavy that uh, some students they need to upgrade their laptops, right? There are a lot of things that this NetBeans can do. And then what we like lecturers ask the students to, okay, you need to memorize this. Okay, type this code. You must know what is a constructor, destructor. Oh, Java, there's no destructor. C++, yes. Constructor, the parameterized constructor, they need to memorize that. Setter, getter, they need to memorize that. But then once they use these NetBeans, when I show them, okay, insert code, right click, constructor. Oops. So they're like, yeah, a semester, we have to memorize all this. Right click, generate. What do you want to generate? Setter, getter. Okay, generate setter, getter. You just select for which variable. Okay, I want it for student name, student ID. Okay, click, I want setter, getter, and then pop, the codes are given to you. So this is how things like the report generator and application generator can really improve the productivity of a programmer. Okay, for when the student use NetBeans, this is where they don't have exam. It's 100% coursework for them. So we're okay with giving them all the tools, because at the end of the day, it's not about exam memorizing codes, but to develop something that is fulfilling the assignment requirement. Okay. Now, so you can see that from the advantages of fourth generation language that is shown here, we see that it's non-procedural. Non-procedural is more English-like, so end user can develop their own application, like they can specify what they want using the query. Okay, and then you can see that it is listed as number one, end users involvement. Now the thing is easy maintenance, because the development time is very fast, quite fast, rapid. It is also cost effective. I add in the explanation here, if you notice, use less time. What does use less time means? It means increased productivity, which leads to lower cost. Okay, so this is what it means by cost effective. But okay, even though the fourth generation language, they are cost effective, there's a downside of it. You can read in this particular sentence, they are slower than conventional programming languages and require much more memory. Okay, more memory required. And another advantages of GL is documentation. So here the documentation is produced at the same time. So the effort to develop the system will be, say, when you do the programming, the documentation is also automated for you. So when this is available, then the system is easier to maintain. Now, question. Now, for this question, you need to explain any three factors to consider when selecting a programming language. So let me bring you back to this slide. What are the criteria for choosing a programming language? Now, so based on this, and let's read the scenario given. ABC Limited is a multinational organization. HQ is in US. They have overseas operations, okay, throughout the world, whereby XYZ Limited is their operation in Malaysia. So let's take a look at the answer. And the first factor would be, can consider using the same programming language as what has been used for their existing application. Okay, the main justification is that for compatibility. Okay, and there's another factor whereby if the HQ they are using certain languages, then we follow the HQ. Okay, the standard as imposed by the HQ in US. But then if you look at the other two factors, we also need to see what we're going to develop. Okay, what we're going to develop. Is it a web-based application? So if it's a web-based application, then we need to select programming language that can do that we can use to develop the web-based application. And need to look at the familiarity of the programming language of the programming team in Malaysia. Okay, so do we have the manpower, okay, programmers who are familiar with the programming language? Okay, so these are some of the suggested answers. Okay, so far, based on this question, anything to ask?
No, no.
Okay, so I'll continue. In case you have any question, you can just type here. Okay, we have 30 minutes left, so let's finish off the last part of our chapter 8, which is on the coding. Okay, remember we want to increase the programmer's productivity. So let's take a look at these case tools. Case tools stands for computer aided software engineering. Normally we will use this case tool to make sure that the system development will be more efficient. Okay, more efficient. We look at what are the things that can be automated um, as what we are looking at in the purpose of the case tool, which is to improve the productivity of the programmer or the SA. It depends if the SA also doing the programming, then we're looking at the SA productivity as well. Some SA, if he is not a full-fledged SA, he might be a AP. AP means analyst programmer. Analyst programmer means he performs both. He performs system analysis and design, and at the same time, he also performs programming. Okay, so we can also look at the SA productivity or the programmer productivity. But then in terms of case two, not so much on programmer because system analyst is the one that is in charge of the whole project lah, okay, in the system development. And another purpose is we use case 2 because we want to obtain or achieve high system quality. Okay, so what are the examples of case 2? Case 2 can help us help the SA to draw the diagrams, okay, like the DFT, and then other automated development tools. So if you look at this slide, the case 2 exists in the 1980s. Okay, 1980s, right? Examples of case 2 that we have are listed here. Some of these are not the latest one, okay? Like what you see here, you can see that this is quite old. Okay, look at the Windows logo. And mostly case tools, they are used to draw the diagrams. Okay, so I can see this is a flow chart. Okay, this is the visible analyst workbench. I see this is a data modeling, okay, your ERD. And then this is extra, the Sci-based Power Designer. I managed to find this one. site-based power designer or builder. In fact, they have this data modeling as well. And if you see, this is this is ERD. Okay, you can see there's tables here, right? There's databases and so on. Okay, look at the tools here. Normally, these are the tools that is easier for us to use. Click, drag and drop. And another extra, this is the Erwin data modeler. Yeah, this one also used for data modeling. You can see that this is your ERD. One thing that I want you all to see is this one. Example of tools where we can do forward engineering and reverse engineering. I will talk about this in the next few slides. A very good case tool will have these tools that allows SA to do this either forward engineering or a reverse engineering. Okay, so let's take a look at the terms and concept for case 2. As what you can see in the diagrams, we use the tools to do the modeling, like to draw DFD, UML. UML is for not for structured approach, it's meant for object-oriented approach. Full name of UML is the Unified Modeling Language. Okay. C++, I think it's an object-oriented language, right? Correct me if I'm wrong.
Which one? C++?
Yes.
I don't know.
Because for C++, you have constructor, destructor, correct? And when you write the code, you will use, what was it already? Because I think only RSDs learning C++ as their programming language, or diploma use C. And I only taught C++ in my previous college, which was more than 10 years ago. Oh yeah, object-oriented programming. I'm not sure whether you all have learned UML or not. Okay. And there's also, besides modeling tools, Case has the documentation tools. So what's nice about this, it will be generated automatically, right? Which is nice when they can find automatically check for us whether there's inconsistencies in our diagrams. You just imagine like your DFD, right? Remember how I checked your DFD last week? Okay, I want to see whether each of your process has at least minimum one input data flow, minimum one output data flow. And then I ask you all, is there any black hole, miracle? How about gray hole? Okay, so case 2 will really improve the productivity of SA because of this. Okay, it's automated for us. Okay, regarding the engineering tools that I showed just now, forward engineering and reverse engineering, this is what it means. Forward engineering means you have the business processes and it is translated into codes. Okay. So for reverse engineering is the other way around. From the codes means the existing application, you break it down into diagrams. This is cool, especially like when you have like in a company, this particular system has already been developed and you say you are required to upgrade this. Okay, so what you can do is you can say to understand how the current system works, you can do reverse engineering. So from the existing application, break it down into diagrams, or perhaps the modules, the structure chart, and then from there it's one way to instead of interviewing user about the current system only, um, the SA can also do a reverse engineering and come up with all these diagrams, source code for understanding the current system more detail. Okay, so we have modeling tools to draw the system model, documentation tools, also engineering tools. Now, under development tools, okay, so we have three tools. Okay, next is the development tools. As mentioned earlier on, a screen generator. I like screen generator. Just click, drag and drop. A report generator, also the same thing. You just click what field you want to include in the report. Okay, and application generator. Let me see. Oh, it mentioned Visual Basic as well. Do you notice whether there's any example of a code in what software are you using? A Visual Net, is it?
Visual Studio.
Visual Studio Net. Is there any like feature in the Visual Studio Net where you can do a right click, insert code, and then it's inserted for you?
Yeah, I guess, yeah.
Ada kah? Let's see if I still have my NetBeans. This is my NetBeans. It's quite heavy. If like previously I'm using like only like 2 gig RAM, my old laptop, it really like takes I don't know how long just to open up IDE. How to give example? This is web app file. I need to have the what do you call that? Okay, insert code. Okay, there's an insert code, and then I can insert what I want. So it will automatically generate for you. Like this is a web app, so it will list out what are the things that can be automatically generated. So this, I believe, will really make life easier for programmer. Okay, there's Visual Basic has something like this. Perhaps.
Oh, I think like heaven, we have to code from scratch.
All from scratch. I see. Do you all have a final exam?
For which subject?
Visual programming.
Yeah.
Oh, okay. I think I understand. Since you all have to, you have a final exam. Yes, you need to remember certain codes. Okay, but I think it will be not that a big problem since it will be an open book. Okay. Now let's continue. That's what I mentioned earlier on, where initially when the student use JCreator, they need to code everything from scratch. I don't know whether I still have my JCreator. Is there any JCreator? I think I. Yeah, yeah, it's no longer here. JCreator is it's like something like a more advanced notepad. You know our notepad, yeah. So imagine the student frustration to type all the codes, but once they are introduced to NetBeans, it's like we have to memorize all this code last semester. Okay. So the keyword of the day, productivity of programmers. Okay, I believe we are almost at the end of our slide. Um, Now we look at another topic, which is using case tool for developing the models. Okay, remember one of the tools available in the case system, we have the modeling tools where we can draw, say, GFT. Now we're talking about this. What's the benefit of developing these models using the case? Okay, so number one, it's easy to draw, easy to store, easy to update. Okay, everything in one location. For I think you all use the what's the name already? Smart no Draw.io. I think it's Draw.io, right? Draw.io.
Yeah.
It's not like it's meant for a particular system. It's like individual diagrams. Okay, individual diagrams that are not related to each other. But then if you use case two, it will be specifically for a particular system, right? And one thing I like about case two is that it enforces standards. Okay, so if you draw a DFD or a certain ERD, then it can notify you whether you have um, violate any rules or not. Okay, like ERD, certain relationship are not allowed. For DFD, you cannot connect data flow from one data store to another data store, right? For Draw.io, when you use it, you simply click, drag and drop, okay, your rectangular, and then you just link all the arrows, but then there's no enforcing of standards. Okay, if you make a mistake, means that's a mistake. For case two, it is able to show you this automatic cross-referencing between models. Example given here is the ERD and ELH. I'm not sure whether you all learn ELH in your database development. ELH stands for Entity Life History, whereby if you have ERD, then you can have an equivalent entity life history for all the entities that you have in your ERD. Let me give you an example, the one that we have covered in our syllabus. DFD. Okay, remember we can use our DFD to generate or to have an equivalent FDD, functional decomposition diagram. All the processes in DFD will become modules in our FDD. So this is an example of automatic cross-referencing. Okay, this is one thing that is nice about case 2. A centralized data dictionary. They have covered this in the database design, right? And then automatic file or program framework. So it will automatically produce the physical file. One thing that I like about certain IDEs is that if they can generate something for you automatically, okay, like Eclipse is what? Eclipse is, I'm not sure whether we can use Eclipse for drawing of diagram. NetBeans, we cannot use it for diagram, but it's more to programming. Here, case 2 is more on the modeling, yeah, more on the modeling. Okay, so another exercise. Okay, what is the question all about? Okay, Mr. Leong, a software development consultant, proposed the use of case 2. Okay, use of case 2 to do what? Drawing and amending the DFD, ERD, and UML diagrams. 3 reasons to justify. Okay, straight from our notes. Yeah, this is the one. Why using case 2 is beneficial in development and maintenance of the models. First, when we draw models, it's easy to draw, store, and update the models. Standards are enforced. There's automatic cross-referencing, there's a centralized data dictionary, and automatic production of the physical file and data structures. Like imagine you draw ERD and automatically it will produce the data structures from the entities defined in your ERD. That's cool, right? So the answers are taken from these two slides. Okay, and in this slide, we still talking about the benefits of case tool, but this time in system development in general as a whole. What we see here is specifically when we want to draw develop models. Okay, this is in general system development. Okay, the first advantage, we can draw descriptive diagrams. Okay, second, we can maintain the diagrams. So the editing facility are there, therefore changes can be made easily. And number three, adhering to the development standards. Okay, like this one is for DFD. We cannot connect a data store to another external entity. That is one of the violation of rules for DFD. Maintaining a data dictionary. Okay, so when we have this, then there's a consistency and cross-referencing check between the data store in the DFD to the entity of ERD. I believe we have covered this when we learn about how to draw DFD, and then after that we learn how to draw the ERD, right? And then there's one part where there's one slide showing us what's the relationship between DFD and ERD. And then normally it will say that all the data stored in the DFD will eventually become entity in ERD. But it's normally not a one-to-one relationship. Okay, so if you want to recall this, you refer to the system analysis, fact recording, if I'm not mistaken, chapter 4. Okay. And then case 2 can be used in prototyping. Remember, we have the application generator, report generator, so it can be done faster, right? And then, this is the application generator, generating the computer codes. Very nice stuff. These are the nice stuff from using the case 2. Next, what are the tools that we can use to support the software development? Case 2, basically we use it used by the SA. Okay, for the whole system development, starting from the system analysis, drawing of the diagrams, okay, and then during the system design, need to draw the data, develop the database design, design the report, all this from system analysis to system design. Use case 2 normally used by SA. Then we are now in the system development phase where programmer will do the coding. Another tool suitable to support software development, as what you all know, is IDE, also mentioned by Mr. Bob last Saturday, integrated development environments. So what is nice about this is that everything is there. It's a comprehensive facilities for programmer to do their software development. Okay, advantages. Since this IDE, they have similar components or similar user interfaces, so it makes it easier to use. But then the disadvantage is that IDE is a complicated piece of software, like for NetBeans that I showed you just now. I'm still learning to use some other features that I haven't used before. So high productivity is only applicable when there's a lengthy learning process, meaning you do the programming every day, so you will discover new things And once you master the whole IDE, how to use it, then your productivity will be very high. And you can see that Visual Studio is listed here, yeah, one of the IDE. Okay, IDE is meant for software development, especially in the coding. And another example is the IBM RSA. We output here what I can see, rational software architect. This is nice. What is nice is that I can see can be used for Java programming, and at the same time can also use it to draw the UML diagrams. Oh, this is very nice. Also can be used for drawing diagrams. I'm not sure about NetBeans though. I think we're already done with the lecture. This is nice, rational. NetBeans. I only know NetBeans can use. Oh, my NetBeans is 8.2. The old one. Edit. View. There's an editor. I think there's no diagram. Yeah, there's no diagram. IDE tools. This is for the web app. Now I remember. For web app, we can also use this to design the user interface. That's why there's a HTML here. Okay, this is a very good example as well. Like for RSL, it's listed here as an example of IDE. And for case 2, it is also listed as a case 2 as well, because we can see that it can perform both things. So it's an IDE, and then at the same time it's also a case 2. Okay, it can do programming and also drawing of models. Okay, so for today, what we have covered is this part. Okay, program coding using tools, the case 2. We look at the advantages of 4th generation language and some other tools that are used to improve the programmer's productivity. Next week, we'll cover program testing and the system documentation.
Miss, why there are 2 box in the slides?
2 box in the slide?
Two boxes. That one. Why like?
Ini?
I could separate into the left side.
Oh, ini. Oh, I mentioned this one earlier. This is the system development, and this is from the system design.
Oh, okay.
Okay, in the system design, this is where up to we learn about the procedural design. Okay, the decision table, decision tree, and then those are used to write the codes. Okay. If you want to capture this, we can capture this because I redraw this one and then I add in. This diagram as shown in the chapter 1 is complete with the 2 deliverable. And then the rest of the chapters, they chop off up until here, missing the final phase. Okay, and then do you see this dash line going back to here at the top? This is to show that SDLC, okay, is a system development life cycle. Okay, it's ongoing. So if the lifetime of the system is 5 years, okay, and then throughout the 5 years, the life cycle will continue if there's say any maintenance request. Okay, so I hope this diagram will help you all to understand the whole SDLC. Okay, so I hope that answers your question. That means, yeah, cannot draw diagram, but for user interface, just now I can see, yes, okay, for the HTML. Okay, so time's up. I believe we have covered for this week's lecture. And for the tutorial, I believe I've assigned you the question, is it? Last week. One moment. So this Thursday we'll discuss this answer lah, tutorial 7. Okay. All right.
Okay.
See you on Thursday. Bye.
Okay, thank you, miss.
Welcome.